All right, I'm back and I'm going to finish up number 26 here. I was just starting to talk about this. See, now this is one, if you notice, all the other ones I've done so far do not skip a piece. But this one goes angle, angle, see, skipping this piece, and then side way over there. Or if you go the other way, angle, skip a piece, angle, side. Angle, angle, side is allowed to skip a piece. Now let's look here. We've got this shared piece in the middle. That's going to be equal to itself, and I've got angle 1, angle 2, and then that side, angle 1, angle 2, and that side. That's angle, angle, side. Now I'm going to show you something here, a little reminder. There are three big ways that information gets hidden in these. The first way, number one, is a shared piece of some kind. Sometimes it's just a shared side, like right there. Sometimes this piece right here is shared. Sometimes they overlap an entire side, kind of like that. You know, you've got to pull that apart into these two triangles, like this one and this one. Sometimes it's a little weirder looking. Sometimes you will share an angle. If you pull that apart, this angle right here will be shared. The second big way that things will be shared is when there's an X. When there's an X in there, you've got these vertical angles right here that will be equal. And sometimes that's a piece of information that's not readily in the drawing. The third way is once in a while, you have a couple of sides of something that are parallel. And if these sides are parallel, oops, that should come over there. Then you have what I call Z angles in there. Whenever you have these parallel sides, and these Z angles are congruent right here. Now that's not the only Z you can pull out of there. Sometimes you've got multiple sets of parallel sides. You could have this Z going this way like this. But you've got to be aware, sometimes you got a Z going this way instead. Sometimes there's more Z's. So watch out for those parallel lines. Your clue that maybe you're looking for some alternate interior angles sometimes in these drawings are these parallel markers. That's kind of a sad little parallel marker. That's a little better. Then see these alternate interior angles right here and right here will be equal. And sometimes that's in those drawings and you don't see it right away. All right, what is the measure of each base angle of an isosceles triangle if its vertex? Whoa, whoa, whoa. Okay, so first of all, what's going on here? This is an isosceles triangle. These are called the legs. This is called the base. The angles here and here, these are the base angles right there and right there. In an isosceles, they're equal. This angle up here is called the vertex angle. Okay, now let me read that again. What's the measure of each base angle of an isosceles triangle if its vertex angle measures 30 degrees? Well, let's see. It's isosceles, so if that one's x, this one's x because they're the same like I just said over here. And the vertex is 30 degrees, so the triangle sum theorem says they all have to add to 180. So x plus 30 equals 180. Thank you, triangle angle sum theorem. That's 2x plus 30 equals 180 minus 30 minus 30. 2x equals 150. Divide by 2, divide by 2. And x is 75. Let's see, what is the measure of each base angle? 75. I think that's it. I have to go back and double check and make sure I'm getting what I'm told. Okay, well, this is interesting. It's kind of a crazy drawing. In triangle QRS, TU and B are midpoints. What are the lengths of TU, UB? Okay, well, as a general rule in a triangle like this, when you've got the midpoint and the midpoint over here, you connect them. This piece is called the mid-segment right here. As a general rule, the mid segment, 2 times the mid segment equals that base of the triangle. It's just that other side, whatever you want to say. It is 1/2 as long, and it is also parallel. It doesn't look like they're asking us anything about the parallel nature of them here. So in all cases, it should be half or double, depending on which way you're taking it. So if this is 50, this should be 25, as these are the two that are parallel. If this is 40 over here, then the one that's parallel to it should be 20. And then finally, if this one is 30, the one that's parallel, that's obviously bigger, should be, oops, not 30, but it should be 60. And that looks good to me. Let's see. If you insist on having equations for that, I can hook you up with some here. And they'll look like this. UT goes with RS, so 2 times UT equals RS. TB goes with QR, so 2 times TB equals QR. And UB goes with QS, so 2 times UB equals QS. You can substitute in the pieces you know and solve those if you wish, but I find that most people can just see it on the drawing. Which of these lengths could be the sides of a triangle? Well, here's what you have to do. You have to take each 2 sides and add them up, and they have to be bigger than the third side, and you really need to do that 3 times. But there's a little shortcut for that, and that is if you add up the 2 smallest, like we'll just do with this top one, 8 plus 7, and make sure it's bigger than the third piece. 8 plus 7 greater than 16, and that's a question we're asking. Is 15 greater than 16? No, and we really don't need to check the other 2, because once you have one set that does not work, the other sets don't matter. So this one, again, we only really need to check the smallest one. 12 plus 16, is that greater than 17? Well, clearly, yes, it's a lot more than 17, so that can make a triangle. How about 9 plus 12 and 21? So 9 plus 12 is greater than 21. Is 21 greater than 21? Now, this is the one that fools people sometimes. A lot of times they put yes. It's got to be greater than. 21 is not greater than 21. It's equal. So the answer is no. Now, if you want to go through the motions on this yes one of checking the other combinations, 17 plus 16 bigger than 12 and 17 plus 12 bigger than 16, you can. But you really only need to check the 2 smallest ones bigger than the third one, and you're done. All right, so number 30. Refer to the figure below. Which segment is longer, A, B, or AD? Well, here's the thing. Here's what makes this work. This one right here and this one are equal. And this one, of course, is equal to itself. So which one of these is open more? It looks like the bottom angle C, angle ACD, is open more. So we'll say 41 is greater than 38, which means the one opposite 41 will be larger than the one opposite 38. So that is AD is going to be greater than AB because it's opposite a larger angle. And what makes that all happen is these other 2 legs are equal. BC is equal to CD and AC is equal to AC in the middle. And since those 2 pairs are equal, that angle dictates these lengths. Measure of each interior angle of a regular pentagon. All right, there's 2 ways to do this. The first way is find the sum of the interior angles of a regular pentagon. Pentagon has 5. The formula is n minus 2 times 180. We'll put 5 in there. 5 minus 2 times 180. That's 3 times 180, and that's 540. Now, if we want to know how big each angle is, because that's the sum total, we'll divide by 5. If you draw a pentagon, you'll see it has 5 sides. It also has 5 angles. Divide 540 by 5, and you get 108. And that is what one interior angle is. Now, there's another way to do that. You can kind of go around, sneak in the side door. We know for this pentagon that one of the exterior angles will make 180 with an interior. Well, we know the sum of the exterior angles of any convex polygon is 360. Well, 360 divided by 5, we know that one exterior angle is 72. Now that's an exterior angle. That's 72 right there. Well, then you know with 180, it has to whatever adds to 180. So 180 minus 72, and it's 108. Doesn't matter which way you do it. You can find it either way, whatever's easier for you. All right, so since we just looked at number 2, this one won't be so tough, that second part of that one. The measure of each exterior angle of a regular hexagon. Well, the fact of the matter is we don't really care how many sides it has. I mean, we need to know for the sake of our problem, but I'm not going to draw it or anything. The sum of the exterior angles is always 360. Always, as opposed to the interior angles, which use this formula right here. But the exteriors are always 360, so 360 divided by 6 should tell us what one of the exterior angles is, and that's 60. So that should be an easy problem as long as you can remember what a hexagon is. All right, find the value of y. Well, okay, first we need to know what the total is here. So 1, 2, 3, 4, 5, 6, 7. This is a 7-sided figure. So using my formula, n minus 2 times 180, 7 minus 2 times 180, and let's see, that's 5 times 180, that's 900. So what it boils down to is all this stuff in here has to add to 900. Let's see. I'll just start by the 1. 116 plus 120 plus 125 plus 135 plus 100. Uh-oh. I messed it up. One more time. 120 plus 116. Oh, I'm going the other way this time. Plus 129 plus 130 plus 135 plus 125. I'm going to check if I have everything. 1, 2, 3, 4, 5, 6 of them. 120, 116, 129, 130, 135, 125, 755. So y plus 755 is 900. So minus 755 minus 755, y equals 145. And if you wanted to write all that out, you could. I don't know why you'd want to, but it'd go y plus 120 plus 116. If I can have my pen listen to me. Plus 116 plus 129 plus 130 plus 135 plus 125 equals 900. If you want to write all that out, you could, but it's just easy to do it on the calculator. In the parallelogram PQLM below, if measure of angle MPQ, let's see, MPQ, that's this angle right here, is 98 degrees, then what is the measure of angle QLM? That's this angle right here. Well, you know what I'm thinking is, let's see, MPQ is 98. What is MLQ? Well, it says this is a parallelogram. And in a parallelogram, opposite pairs of angles are congruent. So this one down here, this angle L and this angle P, the one that consists of both of them, it should be 98 degrees. And the funny thing about this one is, I believe all this stuff in the middle is what they call a distractor in the testing business. It does not matter. That's just there to mess